I'm going to show you how to simplify an expression such as this one, the square root of 5 over the difference of the square root of 2 minus the square root of 5. This is a radical expression, or you could call it a division of radical expressions. Okay, the problem here, it's not simplified because we have radicals or roots in the denominator, and that is not allowed. We can only have rational numbers, or actually integers. All right, so we are going to change the form. We're not going to change the value. So in order to do that, we're going to multiply times 1. Yes, multiply times 1. We're not going to change the value. This one will only change the form. So what 1 are we going to choose? All right. So I have my expression here, and I'm going to multiply times 1. Now, the one I'm going to choose is a fraction, and the denominator will be almost the same as the numerator, but it is called the conjugate because it will be the same two terms with the sign in between them changed. So in this case, the square root of 2 plus the square root of 5. Let's see. Fraction. Square root of 2 times plus the square root of 5. Okay, and this is so that these later they will simplify easier. And because this fraction should be a 1, in the numerator we have to put the same thing. Okay, square root of 2 plus square root of 5. Okay, so now we're actually going to multiply. Square root of 5 times square root of 2 is square root of 10. And square root of 5 times square root of 5 is the square root of 25. So that's what we have right there. Now in the denominator, we will do, using the FOIL method, the first times the first, that's square root of 2 times square root of 2 is square root of 4. So we should write here square root of 4. You can follow along on your paper. Square root of 2, so now the outer ones, square root of 2 times square root of 5, it would be positive the square root of 10, just like here. Then negative square root of 5 times square root of 2 is minus square root of 10. And finally, negative square root of 5 times square root of 5 is square root of 25. And so there we have it. See? Square root of 4 plus square root of 10 minus square root of 10 minus square root of 25. Now it's a matter of simplifying, and you'll see what happens here. Notice those two middle terms, those square roots of 10. We have those. Notice that one is plus and the other one is minus. So what happens to them? Yep, they cancel, they disappear because we're adding opposites and that's 0. So how much is the square root of 25? Yep, it is 5, and the square root of 4 is 2. So what we have here is square root of 10, we can't simplify that, plus 5 over square root of 4, which is 2. These two cancel, and minus square root of 25, which is 5. Of course, 2 minus 5 is negative 3, and that's our answer. That's how you need to write it there. Okay. So I'm going to show you another example of dividing radical expressions, or simplifying an expression with radicals. So let's say now we have this expression which obviously has radicals or roots. 3 minus the square root of 2, all that over 7 plus the square root of 2. The problem here is that there's this square root of 2 in the denominator. We can't have that. We cannot have square roots in the denominator. It's not considered simplified. So what we're going to do this in the same manner as we did the previous problem. We are going to change the form, but not change the value. In order to change the form, we're going to multiply it by 1. So I'm going to copy it. We're going to say that this is equal to the same expression, and I'm going to multiply it times 1. Which 1? A 1 in the form of a fraction. Okay, so I'm going to have a fraction. Now, in the denominator down here, we're going to have the same two terms. So I'm going to write the 7 and the square root of 2. There they are, 7 and the square root of 2. But the difference is that this will have the sign change. This one's positive, so I should write here a negative. There's my negative. Okay, these two binomials, or these two numbers, are called conjugates. They have the same two terms, but the sign is changed between them. Now, because what we want is this thing that we're going to multiply to be a 1, the numerator has to be identical to the denominator. And that would make it 1. There it is. See, the fraction in red is equal to 1. Okay, so now we have to actually do the multiplication. Okay, so we're going to get a fraction, right? There. We're going to start with the denominator here. So 7 times 7, that's 49. And then 7 times negative square root of 2, and that is negative 7 times the square root of 2. And then positive the square root of 2 times 7, so that would be plus 7 square root of 2. And finally, the square root of 2 times negative the square root of 2. And that is positive times a negative is a negative, so negative square root of 4. And that's what we have. Now in the numerator, oh, I have marked these in red. Maybe you can notice something, but it'll make it easier to simplify afterwards. Now we go to the numerator. And we do the same method, the 3 times these two, and this negative square root of 2 times these two. So 3 times 7 is 21. And then 3 times negative square root of 2 is negative 3 times the square root of 2. And then we have negative square root of 2 here times 7, and that would be negative 7 square root of 2. And finally, negative square root of 2 times another negative square root of 2. That would be positive the square root of 4. Okay, so this is our multiplied expression. Okay, now we need to simplify it. Now notice the two red terms. They're identical, except for the sign. One is negative, one is positive. And what happens when you combine them by addition? They become 0. So we have 49. Let's see, 49. I don't need to write this. And minus the square root of 4. How much is the square root of 4? And of course, it's 2. So 49 minus 2. Now in the numerator, notice this square root of 4 again here. Yeah. How much is the square root of 4? 2. So we have 20. Okay, and these two terms, so let me write it. These two terms, notice they have the same radical. So minus 3 square root of 2 minus 7 square root of 2. We add the coefficients. That would be negative 10 square root of 2. And there I have written already the 2 instead of the square root of 4. Okay, we still need to simplify further. 49 minus 2 is, well, I forgot that I would, let's do the numerator first. 21 plus 2 is 23. The square root of 2, 10 times the square root of 2 has nothing to combine it with, so we leave it the same. So there it is. Now in the denominator, it's 49 minus 2, which of course is 47. And that's the expression. And with that, that's another example of dividing radical expressions or simplifying an expression in a fraction form with a radical.